thoughts on perhaps a book or two in the Applications in Cosmology of Light series. And just as a quick overview, this series followed the six-book series on cosmology of light. And basically, in the six-book series, as I had suggested last week, I was seeking to frame the mathematical power of light. And as with any framework, the real applicability of it comes to the surface when one can relate it to contemporary issues that are relevant to the world. And so I chose to take that cosmology of light framework and interpret the fields of quantum computation, genetics, artificial intelligence, and transhumanism from the point of view of a cosmology of light. And so at some point, I'll share thoughts on each of these in more detail. But for now, I want to just focus on this first book, which actually is instrumental to the other books and is also a natural outcome of the Cosmology of Light series. And this book is called The Emperor's Quantum Computer. The reason why I call this The Emperor's Quantum Computer is because we have today a paradigm of quantum computation. And in my perception, there are many gaps with it, and yet it is touted as being close to complete. And I don't think that's possible unless a truer, more deeper nature of phenomena like superposition and entanglement that are fundamental to quantum computation are seen in a deeper light. Now, when one considers a cosmology of light, then that sheds sight onto phenomena like superposition and entanglement. And the reason I think that it perhaps sheds more insight into these phenomena and therefore to the foundation of quantum computation is because in a cosmology of light, there is the essential perception or the foundation that there are multiple layers of light. Now, as I've mentioned before, light itself is not bound, in my perception, by the speed of 186,000 miles per second. That's, of course, the speed we've measured it at. But I think that's more of a convenience because the 186,000 miles per second sets into motion or creates a boundary within which material existence can arise. And this should be evident if we consider the speed of light to be an upper bound, and the upper bound because as any object approaches the speed of light, its mass will tend to infinity, which of course in a material universe is an impossibility, therefore it becomes an upper bound. But then if we take the speed of light and we flip it, or take the inverse of it, then logically that should also yield some kind of lower bound to existence. We find that indeed this could be the case because when we consider what our natural or logical lower bound is, we always think of Planck's constant. And this constant is associated with the way packets are formed at the micro level. And my hypothesis is that there's a particular kind of information or energy that reaches a threshold through the formation of these packets. And as a result, the outcome of reaching that threshold is that that information or energy can materialize, and that's the basis of the formation of matter. Therefore, H becomes a lower bound to existence, but in this point of view, it's inversely proportional to the speed of light c, and therefore a light itself is creating both the upper and lower bound within which material existence arises. That being the case, anything that arises within this framework or within these bounds, I would propose is a result of a persistent quantum level computation. And so when we think about quantum computation from this point of view, then essentially it's the simple way to think about it, and I'm going to go into this in a little more detail, is to imagine that there are multiple layers of light and there are different possibilities that exist within each of these layers. So, as I've just suggested, when we take the layer which is formed by the speed of light c and its inverse h, then there's a particular kind of reality that's materialized due to a particular kind of information. But if we consider light to exist at faster speeds, and this should be a logical possibility because we know that Planck's constant h, when it has the specific value that is associated with it here, then it creates matter in a particular kind of way. But if this h is to reduce its value, then the kind of materialization that would occur would be less binding. So it wouldn't be a materialization as we know it, but perhaps a materialization in the form of waves. And we also have a sense that light itself is a wave particle duality. And then if we further reduce this value of h, we can also logically see that it might give rise to a phenomena of fields. And if we equate h to be zero, then c, or the speed of light, which is the inverse of this, becomes infinite. And therefore, we reach an upper bound to light itself, which is where it travels infinitely fast. And so we have this logical arrangement of layers of light. And each of these layers of light has different kinds of information in it. And it's the arbitration between these different kinds of information that takes place in real time at the quantum veil that, in my perception, really is responsible for the materialization and the possibilities of materialization that arise. So we find at a very simple level, or a first kind of output from this persistent quantum level computation could be space-time energy and gravity, which is a first depiction of a fourfoldness. And then we could have the electromagnetic field also arising as a second output of this persistent computation. And if in the perception or in the model of the cosmology of light that I proposed, essentially the electromagnetic spectrum as it's conceived right now captures two of the four aspects, the electro and the magnetic, which has to do with power and harmony, the electro with power and the magnetic with harmony. But we know, as I've suggested from the previous um, live streams and from the writings in these books, is that there are four fundamental properties in light, and the others are what we can think of as knowledge and presence. And so the electromagnetic spectrum in this point of view, if it's an outcome or if it's a result of this persistent quantum computation, has to also have a fourfoldness to it. And so we can perceive this kind of fourfoldness in the electromagnetic spectrum by considering that the range of wavelengths or the range of frequencies is infinite in the electromagnetic spectrum. And we know that different kinds of wavelengths create, in fact, different kinds of um, possibilities. So we know when we practically consider technologies around us, many of them are the output of specific wavelengths of the electromagnetic spectrum. So whether it's radio waves or microwaves or visible light or infrared or ultraviolet and so on. But each of these has a specific functional difference. And so we can see that this infinity in variation and wavelength could create a repository of archetypal knowledge, which in fact gives us a hint as to the third aspect of the electromagnetic spectrum, which I would call the wave, uh, essentially the wave type archetype. So, and then there's a particular kind of materialization that also could take place depending on what frequency or wavelength is active. And so there's a different kind of mass potential. And we see this, for instance, if we propagate or if we kind of go eons and eons forward, we find that in the human body, for instance, there's sets of organs that are more sensitive to different kinds of frequencies or wavelengths of light, which essentially, if you propagate that backwards to this starting point that I'm suggesting, then it gives us a hint that there's a particular kind of mass that's created due to the different um, frequency or wavelength that exists in the electromagnetic spectrum. And therefore, there's this fourth aspect of presence that I'd call mass potential. So, just summarizing, the second output of quantum computation is wave archetype, electromagnetic, mass potential spectrum. So it becomes a fourfold reality that, in fact, uh, is suggested or predicted by this computation, this fourfold computation that takes place at the quantum veil. And of course, we see this fourfoldness more concretely with the emergence of quantum particles and then with the emergence of atoms in a periodic table or the emergence of molecular plans in a cell. And I'm not going to go into these in a great amount of detail right now, but for instance, there is a fourfoldness in each of these manifestations at the quantum particle level. In the standard model, you've got essentially four types of quantum particles, which are quarks, leptons, bosons, and the Higgs boson. And then when we go to the periodic table, we've got S shell elements, P shell elements, F shell elements, and D shell elements. And then when we further consider the living cell, then the molecular plans in the living cells are also of four types, which are lipids, polysaccharides, proteins, and nucleic acids. So we see this fourfoldness, and in fact, there's a coherence no matter what kind of fourfoldness arises, because we can trace it back to this notion of the four essential properties and light of knowledge, presence, power, and harmony. So this book, Quantum Computation, or the idea behind the Emperor's quantum computation, is that there's something more deliberate. There's something that's, I don't want to use the word deterministic, but there's a qualified determinism in that you have these four possibilities, these very broad properties of knowledge, power, presence, and harmony that manifest and that express more of the infinity of what each of these things means. So knowledge is a very vast concept, and there's many different kinds of ways to think about knowledge and variations of knowledge. So one can perceive that this thing that we call knowledge is actually a set of infinite elements all related to knowledge. And similarly, we have infinite sets that are related to power, to harmony, and to presence. And as this persistent, continuous quantum computation occurs at the cosmic level, and manifests at this quantum veil, we see the possibility that this fourfoldness becomes more and more elaborate. So we can see this, for example, in the human cell, where you have 30,000 different types of proteins in the human cell, and proteins being, for example, an outcome of this concept we're calling presence. But if you kind of go back a little bit, then presence means something less. At the periodic table level, you have a certain number of elements that I'll argue are the D shell elements. So there's a finite number of D shell elements that all display some aspect of this property of presence. And then when you project forward to the human cell, then that number increases exponentially. And so the idea is that all these possibilities are contained in this thing that we're calling knowledge, presence, power, and harmony. But then with each subsequent computation, as you will, more of the fullness comes out. And so there's something entirely different about the possibility of quantum computation. In today's world, what we really um, are trying to do, I think, is we've been uh, habituated by our success in digital computation, and there's certain kinds of problems we can solve. There's certain possibilities we can create with digital computing, and we're trying to apply that same thing, I think, to quantum computation. But that to me is a fallacy, because the very notion of quantum computation is something entirely different. It's a very creative, as opposed to the constructive paradigm that animates digital computation. And so, in this creative quantum computation, there's emergences that you wouldn't be able to predict. So when matter arises through the play of quantum particles and through the play of various atoms, then you wouldn't necessarily have predicted that life can arise, but yet it does. And then you wouldn't have predicted that mind can arise, and yet it does. And we may think that that mind is the end of this computation, but why should it be? And there should be other kinds of emergences that are entirely possible. But we might be able to have a glimpse of these kinds of emergences if, in fact, we consider light to be the foundation of this entire edifice of computation. So, another big difference in today's view of quantum computation, which is a hangover from digital computation, is that computation itself should be what's called substrate independent. And that means that it doesn't matter what kind of matter you use to have these computations occur in, so long as the matter itself can have a few different stable states that will create memory, and so long as you can manipulate some of these states in matter to emulate different functions, then you have the basis of computation. And so it becomes substrate independent. But in fact, what I'm arguing in the whole cosmology of light is that the substrate that exists is extremely important. And why is it extremely important? Because it's the output of this computation whereby light itself precipitates and materializes into all this vast potentiality and diversity that's actualized. So, that infinity in light, when we think about light's native state, light existing infinitely fast, then we can, as I've suggested before, that in that infinitely fast reality, we can hypothesize that there's an omnipresence, omnipotence, omniscience, and omniharmony. Why? Because a light in whatever volume we consider, if it moves infinitely fast, will be present through that entire volume instantaneously. If anything arises or disappears in the fabric of light, it will be recorded. So there's an omniscience. It knows everything that's happening. Everything is connected in the nature of light. So there's an omniharmony. And if anything not the nature of light arises, it will be subsumed or overcome by the nature of light. And therefore there's an omnipotence. But the very fact that you have these four um, omni characteristics implies that there's infinite information that exists in that state. And this infinite information is the basis of infinite potential. And it's through various acts of quantization as light precipitates at slower and slower speeds, there's a different kind of quantization that's occurring where information is being gathered in a particular way to express itself in a particular way. And so you see more and more of that infinity being expressed materially. And then at this layer where speed exists at c, as I proposed, because you have this vast information that all of a sudden wants to materialize in something that's more material as opposed to subtle, that precipitates or that initiates this big bang that supposedly is a starting point of our material universe. And through that big bang, it's essentially an act where you've got this infinite potential in information existing when light travels infinitely fast, showing itself materially at this realm where light exists at speed c. And so quantum computation, when you think about it from this point of view, is something very, very spectacular. Its magnitude is much more immense. Its possibilities are much more immense. It becomes a fundamentally creative act by which the cosmos expresses what it what is contained within it, or what is at its source in these layers of light. And so our thinking or our perception of quantum computation needs, in my point of view, or this point of view of cosmology of light, needs to be expanded very thoroughly. And we are just at the kind of like surface of what's possible, and there's so much more possible. I mean, we say, for instance, when we talk about quantum computation, that there's these phenomena, this quantum phenomena called superposition and entanglement, and then if I go further, there's phenomena like tunneling and annealing, quantum annealing, and it's due to these different phenomena that the possibility of quantum computation arises. But what exactly is superposition? What's entanglement? What is tunneling? What is annealing? These have to be interpreted, I think, in a different way than they are right now. Superposition, as it is currently seen, is where you have this qubit or you have this quantum possibility that can exist in infinite states, and it just then materializes due to an act of observation into something more concrete. But if we think about superposition from the point of view of multiple layers of light, then the concept that materializes has a counterpart at more and more subtle layers, going back to that layer where light's traveling infinitely fast. And so superposition takes on a different meaning. because there's a superset that then becomes a subset that becomes something even more concrete, though subtle, and then materializes. So superposition means something different. When we think about entanglement, entanglement is, since everything materially did arise from a single starting point when that Big Bang occurred, by definition, everything is completely entangled. But when we talk about entanglement in today's dialogue, then we talk about entangling, say, two quantum particles together that then share knowledge across time and space. But the point is that everything shares knowledge across time and space because it's been entangled at the source. Um, so how do we think about entanglement differently? There's a different way to think about entanglement, and there's different kinds of possibilities that arise. And so, we can see that even the way that we've perceived some of these fundamental ideas of what a quanta is, of what superposition is, of what entanglement is, in my perception, needs to be expanded out, and it's going to create different technological possibilities in the field of quantum computation. And unless we begin to change our paradigm of what's at the basis of this computation, which I'm saying is the play and the arbitration of layers of light, then we by definition cannot create what could be created. And that really is what this idea of a light-based quantum computation is pointing at.